The lesson topic for this video is calculating reference angles. In the previous lesson, we described what a reference angle is, and we talked about how we will label it theta prime. We'll continue to use that language today. So for starters here, I just want to have us draw a 160-degree angle in standard position. So go ahead and draw that in your notes. Standard position, that means the vertex is on the origin, and the initial side of the angle is on the x-axis, the positive x-axis. 160 degrees is 20 degrees less than 180, so probably right around here. There is our 160-degree angle in standard position. Now we're going to label theta prime, the reference angle. All right? If you remember from the previous lesson, the reference angle's definition is the angle created by the terminal side of the angle that we started with and the nearest x-axis. All right, so the two portions of the x-axis, this is one portion over here on the right, and this is the other portion of the x-axis over here. So if we're creating theta prime using the terminal side of the angle and the closest x-axis, this right here, I should have written this in red, this right here is theta prime. Theta prime. Now, question 3, or statement 3 says, can we find the measure of theta prime? The answer is yes, we can find the measure of that angle. If you think about it for a second, this angle is right here is 160 degrees, and then to get from this terminal side to the x-axis right here, how many degrees further do we need to go to get there, to the 180-degree point right there? Well, we needed to go 20 degrees. So yep, theta prime is 20 degrees. Here are two more examples of the same type because different things happen depending on where theta prime is located. Sometimes people want to generalize how to find theta prime by simply saying, oh, subtract from 180 or something of that sort, but it is not always the same, and every situation should be looked at differently. So let's take a look at the second one. Draw a 205-degree angle in standard position. Okay, this right here is 225, this is 180, so a 205-degree angle would be somewhere in this region here. So that's a 205-degree angle. Now where is theta prime? Okay, theta prime is created once again with the terminal side of the original angle and the nearest x-axis, which is right here. So here's theta prime right here. Theta, it's so hard to draw on this, sorry, theta prime. All right, that's theta prime. Once again, can we find the measure of that? Sure. Okay, if we had this original ray at a 205-degree angle, and theta prime is in between the 180 and the 205-degree angle, we need to find how far we have to go from 180 to 205. Well, 180 to 200 would be 20 degrees, and we have to go 5 further to get to 205, so this is a 25-degree angle. Again, I don't like to make generalizations about, oh, add to 180, subtract from 180, because it's not even always with 180. Let's look at the next one. So, original angle, 315 degrees, is right, whoa, there. Now we're going to label theta prime. Theta prime is the angle created by the terminal side of the original angle and the nearest x-axis. The nearest x-axis is right here, so the angle we're talking about is right here. This is theta prime. What's the measure of theta prime? Well, this time we need to think about how we're at 315, and to get to the x-axis we need to get to 360. Well, how many degrees is it from 315 to 360? The answer is 45 degrees. You may want to just practice a few more of these if interested to make sure that you are on the right track, because this skill right here is super important for what we are going to do in the next couple of lessons. If not, just carry on and get to the next slide. Otherwise, pause it, try them on your own, and restart the video. Okay, and these are the answers to those 3 problems. If you check them, let me know in class if you have any questions on these. Okay, now in this example, we're going to throw a little something new here. So it says if 4, -13 is a point on the terminal side of an angle in standard position, do the following 3 things. Now before we read those 3 things, I'm going to go ahead and put that point into our diagram. So 4, -13. Now this can be estimated, but just think about where 4, -13 would be. 4 over on the x-axis, so let's say 1, 2, 3, 4, and -13 on our y-axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Well, that's not the best, but you know, it'll work. 4, -13 is right here. So there is the point 4, -13. Now what does it say in the directions? It says that the point 4, -13 is a point on the terminal side of an angle in standard position, which means I'm going to take from the origin, I'm going to draw a line that creates my terminal side of my angle in standard position. I'm also draw the original or initial side of that angle as well. So let's make sure that this makes sense. Is it true that 4, -13, which is right here, is a point on the terminal side of an angle that's in standard position? Yes, it is. So we drew the angle, and now what we want to do is we want to label the reference angle theta prime. Now we know that this right here, this whole angle here, is our original angle. We could call that theta, right? So where's theta prime? Well, let's remember that theta prime is an angle that has, one ray from the terminal side of the original angle, which is this, and the other side of the reference angle is the nearest x-axis. So here's the nearest x-axis to this terminal side. The other part of the x-axis is over here. That's further away. So here is my terminal side and the nearest x-axis. So this right here is theta prime. And a really ugly color orange. Okay, so that's theta prime. And now the directions say connect your point to the x-axis. And what I mean by the x-axis is the x-axis that we just used, the nearest x-axis that we just used to create theta prime. So we're going to connect this point down here, the point 4, -13, we're going to connect that with this x-axis up here. So what happens? Well, what happens is we just formed a right triangle. Okay? Because if we connected this point straight up to the x-axis, this right here is a right angle. And that will be helpful because we will be able to use this right triangle right here to find missing things using trig. Okay, so let's try another one of these using the coordinate plane shown. All right, so given a point on the terminal side of theta, label the reference angle theta prime, then draw the right triangle formed with the reference angle. All right, so first of all, we're going to put a point at -7, 6. Now I did show some little tick marks in the previous example. We don't need to put those in. So -7 on the x-axis and then 6 on the y-axis will be somewhere in this region right here. Okay. Now, that point is on the terminal side of theta prime, so I'm going to go ahead and draw my initial side right here and my terminal side right here. And I'm going to label that as my theta, my angle that is theta, and I'm going to find theta prime. Well, theta prime is the angle that's created with the terminal side and the nearest x-axis, which is right here. So this right here is theta prime. Then we're going to draw the right triangle that is formed with the reference angle. So we're going to draw the right triangle from that point straight to the x-axis that we were just using for theta prime. That's all we need to do there. If you'd like, go ahead and try these last two. Make sure to check them out with me in class if you do not get them drawn in correctly. All right, this is what they should look like.